Welcome back to Start E-Learning. In last class, we have discussed about the different distance measures such as Euclidean distance, Manhattan distance, and Jacquard similarity, cosine similarity, Minkowski distance, Chebyshev distance. Likewise, we have discussed all the distance measures which are used in the machine learning. Now, in this video, we will see how these hyperplanes, subspace and half spaces would be. We'll completely understand everything about this hyperplane, subspace and half space. Without wasting time, let's skip into today's topic, hyperplane. So hyperplane is a geometrical entity whose dimension is one less than that of in ambient space. So without this particular definition, we'll try to understand it over here. See here, assume that if it is a three-dimensional geometry, so there is a plane which is lying in this. Assume that this is what the plane in this three-dimensional geometry, which is having x, y, z as ordinates. X, y, z are the ordinates. So see here, when we see with the naked eyes, see here how it would be. So it's looking like in 2D, right? So in the same way, you have to understand this as a hyperplane is a geometrical entity whose dimension is 1 less than that of in its ambient space. So here the in this particular example, the ambient space is the 3D three-dimensional geometry. But when we are seeing, it's looking like it's in 2D, right? So this is what the meaning for this particular line. Okay, hyperplane is a geometrical entity whose dimension is 1 less than that of its ambient space. So this is what the detailed description about this particular one. So it means that the following, for example, if you take a 3D space, then the hyperplane is a geometrical entity that is one dimensional less. So it's going to be two dimensions. So that's what I explained in this example. So whenever it is in the 3D geometry, when we come to the hyperplane, it would be like one dimensional less than. Okay, so if it is ND, this hyperplane would be of n minus 1 dimensions. Okay, so n minus 1 definition. Next, dimensional, okay, two-dimensional entity in the 3D space. Okay, now if you have a two dimensions, then one dimensionless would be the single dimensional geometry entity. Okay, so in the same way, when we have the 2D geometry line, when you have 2D geometry, when I draw that line, in the sense it would be looking like a one dimensional geometry, right? So this is what the definition for this hyperplane. So the hyperplane is usually described by using an equation as follows. So x transpose n plus b equals to 0. So this is what the equation of this particular hyperplane. Now we are in the discussion of the hyperplanes, right? We'll see how this particular definition will be available. Okay. So as we know, in 2D geometry, the equation of the line, let's draw the diagram and try to derive it. So assume that this is a 2D geometry. So this is horizon, this is x-axis, and this is y-axis. Assume that there is a line passing in a 2D geometry. So this is what the line which is passing in the 2D geometry. So equation of the line. So in slope intercept form, we write this equation as y equals to mx plus c, right? So in general, the equation of the line is represented as, see here, ax plus by plus c equals to 0, right? So this is what the equation of the line in two-dimensional geometry, that is 2D geometry. So we can convert this particular 2D form of the line to slope intercept form by using, see here, so we can convert this to this form by using by equals to minus ax minus c, y equals to minus a by b into x minus c by b. So this is what the notation for this. So as we know, in the slope intercept form of this line, This m represent the slope, right? Slope. So if I wanted to find this particular slope in the sense, so minus a by b, okay, m equals to minus a by b. And then if I wanted to find out this c value in the sense, minus c by b. So c is nothing but what the constant value which is given in the 2D line. Okay, so this is what the equation of the line in the 2D geometry. When we come to the 3D geometry, assume that this is as 3D geometry. So assume one plane is in this particular 3D. So this is x, this is y, this is z axis, and this is what the plane which is in this, and 0, 0, 0. So this is what the origin over here. Okay. Now this equation of this particular line of the plane in this particular 3D geometry is represented as ax plus by plus cz plus t equals to 0, right? So this is what the equation of the line in what? 3D geometry. What about the n dimensional? So assume that we have n number of dimensions. At that case, this particular equation can be ax plus by plus cz plus d some coordinates. So okay, d s plus and so on plus something z equals to 0. So this is what the equation of this particular line in the n-dimensional geometry, right? So I can see here, assume the x-axis as x1, y-axis as y1, and z-axis as x2, and this z-axis as x3. So we can replace these particular values in this equation, right? So ax1 plus bx2 plus cx3 plus and so on z equals to 0. So here we have different types of variables, right? So I am assuming these particular values as, see here, these particular variables as n, or it may be x. So whatever it may be, you can transform these variables into one thing. So that might be easy to derive this hyperplane. Okay. So I am taking these particular variables as w. Okay. So here in this case n, right? So now I will take these values as, assume that there is a vector that is n which is having all these values. Okay. So I am replacing a as n1 and b as n2, c as n3, likewise. So I am converting these particular variables into like this. Okay. See here. This is n1x1 plus n2x2 plus n3x3 plus and so on plus, so I am taking this as n naught. Okay, n naught, or here in this equation it's b, right? So simply I will take this as b equals to 0. So we can write this as, so b plus summation of n equals to 1 to n, or else you can take I. Okay, I equals to 1 to n ni xi equals to 0. Okay, so here I values ranges from 1 to up to n. Okay, so this is how it's mentioned over here. So here also the dimensions also I am going to form one vector. Okay, basically these particular dimensions are in vector, right? So see here, x equals to, this is x1, x2, x3, x4 and so on, likewise. So now I can replace, so if I want this particular equation, right? So for that, see here, x is a vector, b plus x is a vector. I'll write this vector as it is and this as it is. Now first I'll write this vector n1, okay, in the same way n2, n3 and so on. Then into, so I'm transposing this particular x, okay. So when I transpose this particular x in the sense, it will be converted as x1, x2, x3 and so on, right? So it will convert like this: x1, x2, x3, x4 and so on equals to 0. See here, when I multiply this particular vector with this vector in the sense, finally we will get this result, okay. Now I'll replace these particular vectors by its names, okay. See here, b plus, this is n in the sense, simply I am writing n and it is x transpose, right? So equals to 0. So this is what the equation of this hyperplane. This is how the derivation of this particular hyperplane is. And then when we hyperplane. So if we expand this out for n variables, we will get something like this. Okay. So here x is nothing but a vector having x1, x2 and so on xn. Okay. And n is nothing but it's having n1, n2, n is also a vector which is having the elements like this. Okay, here we are expanding this particular equation of the hyperplane into n variables. Okay, so in just 2 dimensions we will get something like this is nothing but the equation of the line. Okay, if I have the 2-dimensional geometry, so see here, assume that this is the 2D plane having x and y, x and y. So whenever the line which is passing through this particular 2D geometry, the equation of the line is referred to be as ax plus by plus c equals to 0, right? So this is how it would be mentioned. In the same way, if when I take it in the two variables, okay, two variables, so this equation would be looking like this: x1 n1 plus x2 n2 plus b equals to 0. So this is what the equation of the line in the 2D geometry. Okay, now we will see the example for this hyperplane. Let's consider a 2D geometry with, here they are given the constants, that is the coefficients. See here, 1 and 3 are the coefficients which they are given, and b is the constant, so that value is a 4. Okay, so thought though it's in a 2D geometry, the values of x will be, so here we are assuming that, see here in normal notation, this is x and y, right? So here I am assuming this particular x as x1 and this particular y as y2. Okay, likewise sorry, x2 I'm assuming like this. So that's why I mentioned the vector like this. Okay, x equals to x1 and x2, likewise I mentioned over here. So that's why x equals to x1 into x2. As we know, the equation of this hyperplane would be x transpose n plus b equals to 0, right? So b, which is the constant. Here x transpose, so I am going to transpose this particular value. Here n is given the vector like this. Now I am substituting this in this equation. See here, this is what, so when I transpose this particular x, it would be x1 and x2, right? So this is how it would be. So here, see here, that's what I mentioned over here, x1 and x2 into n value is 1 and 3, right? So here I am multiplying this particular value and I am getting this. So in the question itself they are given that the b value is 4, I mentioned over here, likewise. So now I got the equation of the line in the 2D geometry. So As you can see from the solution, the hyperplane is the equation of the line. Okay, that hyperplane become the equation of the line. So hope you people got it. Then we will discuss about this subspace. As we know, the equation of the hyperplane is what? X transpose plus n plus x transpose n plus b equals to 0, right? So this is what the equation of the hyperplane, which is not going through the origin. Okay, so if it is going through the origin, assume that this is what the plane which is going to through the origin in the sense. So at that case that there is no b value. Okay, we'll explain. See here. So if it is equation, if the equation of the line in the 2D geometry, if it is passing through the origin in the sense, in the slope intercept form, it would be y equals to mx. So there is no c value. That's why hyperplanes in general are not subspaces. However, if we have the hyperplanes are of the form, so x transpose n equals to 0, where the b is not there. Okay, so that is, if the plane goes through the origin, then a hyperplane also becomes a subspace. Okay, this is what the subspace.
Come to the subspace, we have subspace, right? Subspace is nothing but whenever the particular plane which is passing through the origin. So please try to understand that whenever this particular plane is passing through this origin in the sense, at that case, what will be the value? So this particular constant will not be there, right? So assume that this is the line passing through the origin. So equation of this particular line would be y equals to mx. So in slope intercept form, its value is y equals to mx, because so this c value is 0, right? So it's not passing, it's passing through origin. That's why c value is what? 0. So in the same way, whenever this particular plane is passing through the origin, at that case, this particular equation will be transformed as x transpose n equals to 0. So what it specifies? It is subspace. Subspace. So this is what the equation of the subspace is. Okay. You just to try to remember one thing, that whenever the plane which is passing through this origin in the sense, at that case it forms a subspace. Next, in our syllabus, next we have what? Positive half space, negative half space, and on the line, right? So we'll just try to understand that particular concept. Okay, assume that there is a line. See here. So this is what something line x, y. This is origin. So this is the line which is in the two-dimensional geometry. Assume that the equation of this particular line as 2x plus 3y plus 7 equals to 0. So this is what the equation of this particular line. So here, if it is equals to 0 in the sense, it is lying over here. That is, this is what the line is. If positive half space is, see here, this is what the positive half space, or positive half plane or plane. Next, this particular region is said to be a negative half space or the plane. Okay. So we have three cases. So in case 1, if this particular equation of the line, so in general you just remove this 0 and see here, 2x plus 3y plus 7 equals to 0. If it is equals to 0 in the sense this is lying on the line. Okay, assume that there is a line. uh, so I am taking one line. Same, if that is equals to this line, the line which is existed in our 2D geometry, in the sense at that case this is said to be on the line. Okay, this is on the line. So in the second case, if 2x plus 3y plus 7 is greater than 0 in the sense, at that case the line which we have taken is on the positive half plane or the space. So in case 3, if 2x plus 3y plus 7 is less than 0 in the sense, in this particular case it lies on the line which we are mentioning over there. This particular line is on the negative half plane or the space, right? So
Next, half space. So this and all, as we discussed in the board itself, see here, I assume that this is the equation of the line. So if it is greater than 0, it is in the half plane or the half space. So if it is less than 0, it is in the negative space. Okay, so this is what the detailed this is what the detailed description of it. Okay, now, so for these two dimensions, we could write this line as we discussed previously. So, in the board itself, we have discussed this. So, we have taken one example, and so if it is equals to 0 in the sense, it is on the line, and if it is greater than 0, it is on the half space. If it is a positive half space, and then if it is less than 0, it is in the negative half space. So we will discuss in detail over here. Let's consider the sample example that we have taken in the hyperplane case. So by solving, we got the equation as x1 plus 3x2 plus 4 equals to 0. There may arise three cases. So let's discuss each case with the example. Okay, so x1 plus 3x2 plus 4 equals to 0. So let us consider the points. See here, assume that this is as x and y. So if I consider these values and substitute these values into the equation in the sense, so let's substitute these values. So x1 is nothing but minus 1 plus minus into 3, in the sense minus 3 plus 4. It is minus 4 plus 4 equals to 0. Okay, so this point, if I substitute this point, I am getting the 0 as a value. That's why it is on the line. In case 2, let us assume this value. Okay, x as 1 and y as minus 1. So I am substituting x1 plus, I am substituting this value. Okay, minus 3 plus 4. Okay, see here, minus 3 plus 5. What it would be? 2, right? So here we are getting the positive value. That's why it is in the positive half space. Okay, so when I consider these particular points, see here, 1 and minus 2 I am taking in this case. Okay, when I substitute this particular value, 1 plus 3 times of minus 2, in the sense it would be minus 6 plus 4, and then plus 4, right? It is plus 4. 4 plus 5 minus 6 plus 5 minus 1. Here I am getting the negative value. Okay, so which is less than 0, that is it lies on the negative half space. So
hope you people understood this concept. See here, If it is equals to 0 in the sense it's on the line. If it is greater than 0 in the sense it is in the positive half plane or the positive half space. Okay, so if it is less than 0 in the sense it is in the negative half plane or the space. Hope you people have got it.